Good evening. This is your live lesson from Tuesday, September 8th, what happened in class today. So we have several things we're going to cover today. Factors and multiples. So if we look at our I can statements, I can find the factors of a whole number, find the common factors of two whole numbers, identify prime and composite numbers, find the multiples of a whole number, find common multiples of two whole numbers. So if you have watched the pre-class video, you would have taken notes on the vocabulary that we are covering here. And factors is something that we've been working with over the past 3-4 weeks or so when we are finding factors of a number to decide if it's prime or composite. So let's go ahead and take a look at what we have. So just as a review, when we use arrays, we can identify prime or composite numbers. So arrays are in the shape of rectangles or squares. So looking at the number 16, we have 2 times 8 for 16. We have 4 times 4 for 16. And we have 1 times 16. I apologize. My dog is here making all kinds of noise. So if you notice, each one of these models for 16 is in the shape of a square or a rectangle. Now, if we look at the number 7, we have 1 times 7. And then over here in this model, we have a remainder. So the part that does not fit evenly into a square or a rectangle is a remainder. So that shows us that the only way to make an area or an array for 7 is 1 times 7. And then we look at 9, we have 1 times 9, and we have 3 times 3. So that means that our numbers are composite for 16, prime for number 7, because the only way to make 7 is 1 times 7, and then composite for 9, because the way to make 9 is 1 times 9 and 3 times 3. Those are my factors for 7. Those are my factors for 16. We have 1, 2, 4, 8, and 16. Okay, make sure you're taking notes. You can always pause the video if it's going too fast. So look at our numbers of the day. We have the numbers 1 and the numbers 2. So listing the factors for 1 and 2 in your notebook. And then we have to determine what kind of numbers they are. So the factors for 1 are 1 times 1. That means 1 is its factor. The factors for 2 are 1 times 2, which means 1 and 2 are their factors. So the number 1 has only one factor, and that makes it neither prime or composite. One does not fit the definition of 2 or more factors. Excuse me, 2 or more factors. So that's why it's neither prime or composite. And actually, 0 and 1 are neither prime or composite. And the number 2 has exactly 2 factors. So notice this here, we're saying that 2 is our first prime number. Okay, make sure you write these on your journal and take notes, because this will be important later on in our lessons. Okay, so I'm going to extend my whiteboard here a little bit. and we're going to talk about some numbers, prime and composite. So the reason you need to know what's prime and what's composite, or the way they might ask you in a test, is they might say, in the month of August, how many days are prime or composite? So we're going to review some rules. Okay. So the first rule is even numbers. Okay, so what's an even number? An even number is any number that can be divided by 2 evenly. Okay, even numbers are not prime, they're composite, with the exception that 2 is our first prime number. And even though it is even, the factors for 2 are 1 times 2. That's it. We just did that in our daily lesson. So even numbers can be divided evenly by 2, are not prime, they are composite. So let's talk about what even numbers are. Even numbers, so when you skip count by 2, numbers that end in 2, 4, 6, 8, 10, 12, so on. And you can see that the 2 starts to repeat. So if we look at our calendar, 4 is divided by 2, so it's composite. 6 can be divided by 2. And I'm just going to look through at all my even numbers and mark them off, because I know that they can be divided by 2 evenly, not having a remainder. So that makes them composite. Okay, my second rule, numbers that end in 5 or 0. They can be divided by 5 evenly. So when we talk about even numbers, we have numbers that end in 0. So now we can look at numbers that end in 5. Again, we have an exception here. We have the number 5. It ends in a 5, but the only factors for 5 are 1 and 5. So when we look at our numbers 1 through, let's say, about 15, you're going to see a lot of prime numbers because they're smaller numbers and there's very few ways to make them. So if I go back and look at numbers that end in 5, I have 15. Well, 15, 1 times 15, 3 times 5. Okay, we already got our zeros. Then I have the number 25. 1 times 25, 5 times 5. So 25 is a composite number. And then our third rule that we're going to discuss today, numbers that can be divided by 3 evenly. I might just change this to the division symbol. So again, we have a few exceptions. 3 has the only factors of 1 and 3. And I think we used this in one of our examples. I know we use 7 as one of our daily numbers. So 1 times 7. So we have 1 times 3, 1 times 7, 1 times 5. That's why they are prime numbers. Okay, let's look at the number 9. 9 can be divided by 3 evenly, and we just saw that in our example. So that makes it composite. And we're going to cross off 1 because 1 is neither prime or composite. So we're going to look at 11. Can 11 be divided by 3 evenly, or 5, or 2? Well, 11's an odd number, so I know it can't be divided by 2. If I skip count by 5s, I pass 11, so it can't be divided by 5. And if I try to divide 11 by 3, I get 9, and 2 is a remainder. So that means 11 is a prime number. One thing you can always use for numbers that are kind of small but fit within your multiplication table is look at your multiplication table. Do you see these numbers there? If they're not there, that means that they are prime because the only way you can make them are 1 times the number. 13 would be our next prime because the only way to make 13 is 1 times 13. 17 would be our next prime. 19. If you're not sure why I'm getting these numbers, let's just try it. 17 divided by 3. 3 times 6 is 18. That's too big. So I have to use 3 times 5, 15, remainder 2. Can't have a remainder when I'm dividing. Let's check 19. 19 times 3, or 3 divided into 19. Now I can try 6. That's 18, remainder 1. That's not going to work. It's an odd number, so 2 will not divide into it evenly. And that's the key. You have to have numbers that can be divided evenly. So let's look at 21. Is 21 prime or composite? Well, it's an odd number, so I know it can't be divided by 2. Can I divide 21 by 3? If you look at your multiplication table, you'll see that 3 times 7 is 21. So that makes it composite. That gives me another set of factors. So it's 1, 3, 7, and 21. What about 23? Well, if I 23, that would be 21. If I keep that 7 up there, remainder 2, that's not going to work. If I count by 5s, it doesn't end in a 5 or a 0, so that's not going to work. So that makes 23 a prime number. All right, what about 27? It's not even, so I can't divide it by 2. If you look at your multiplication chart, you'll see that 9 divides into 27, or 3 times 9 equals 27. So that makes it composite. And then we have 29 and 31. So it would be helpful if you memorize these because these are your first few primes. So in the month of August, and that's going to be how you'll be tested. They'll just say, how many days in the month of August are prime? And the thing you need to know is that August has 31 days. And so if I start counting, that's 1, 2, 3, 4, 5, 6, 7, 8. Oh, I skipped one. 9, 10, 11. There are 11 prime days in the month of August. Okay, so what I would like for you to do, and make sure you do this, is to make this calendar or table in your notebook. Now, you don't have to make it an August calendar. You can just make a table that lists the numbers from 1 to 30, 31. You can just make it a table and just start writing 1, 2, and make sure that you identify which numbers are prime and composite like I have. So you can just make a table like that. Pause the video if you need more time. Okay. So let's go back to our slides. So look at the numbers we have listed. I'm asking for the factors of 15 and 20. And remember, factors are the two numbers that you multiply together to get a number. So the factors for 15 are 1 times 15, 3 times 5. So my factors are 1, 3, 5, and 15. The factors for 20 are 1 times 20, 2 times 10, 4 times 5. So 1, 2, 4, 5, 10, and 20. So in our question, it's asking for the common factors. Well, another word for common is same. So if I look here, I have 1 and 1, or 1 here. Then I have 5 and 5. So my common factors are 1 and 5. The GCF, or the greatest, so we're looking for the biggest same factor, and that's going to be 5. Okay, make sure you write these in your notebook, because if you're not writing, you're not learning. All right, now we're talking about multiples. Multiples are different than factors. Factors are the two numbers we multiply together, and multiples are like skip counting. So 6, 12, 18, 24, 30, 36, 42, 48, 54, 60, 66, 72. And then for 9, we have 9, 18, 36. Oh, I skipped one. 9, 18, 27. 27, 36, 45, 54, 63, 72, 81, 90, 99, 108. Okay, what are the common multiples? Well, let's see. We've got 18 and 18. I see 36 and 36. 54, 54, 72, and 72. And if I kept going with 6s, I might find more, but this gives us enough of an idea. So the common multiples, and I'm just talking about the multiples through 12s, are 18, 36, 54, 72. The least, the small one, is going to be 18. So this is going to be important as we move into equivalent fractions. Make sure you take these notes in your notebook. Okay, your last assignment for today in your notebook is to identify whether these numbers are prime and composite. That's one thing. And then here you're going to list the factors for 14 and 21, whether it's prime or composite, what are the common factors. So here we're talking about factors. And then on the other side, we're talking about multiples. All right. Factors of 14. 1, 2, 7, 14. 21. 1, 3, 7, 21. Composite, because they have more than two factors. The common factors are 1 and 7, and the greatest common factor is 7. Now we're going to look at our multiples. We just did the 9s. 9s, 18, 27, 36, 45, 54, 63, 72. That's not going to give me space. 81, 90, 99, 108. Let me go to a different color since I'm running out of space here. Maybe I can stretch this a little. There we go. Okay, so let's look at our multiples for 12. Let's see if I'll list them over this way. We have 12, 24, 36, 48, 60, 72, 84, 96, 108. So both numbers are then composite. And we've already done these numbers, so you should have them on your list. Make sure you add any new numbers to your list. So what are the common multiples of 9 and 12? Let's see, I see 36 and 36, 72, and 108. So the common multiples are, let me change colors here so you can see them. 36, 72, 108. What's the least common multiple? 36. Okay, so make sure you write these in your notes. The difference between factors and multiples. Multiples is like skip counting by that number. Factors are the two numbers you multiply together to get an answer. Make sure you go to your Schoology folder and complete today's assignments. We'll see you all in class tomorrow.